So I want to talk a little bit about this blurring of the line between the physical world that we all inhabit and the digital worlds that increasingly we are creating. But I want to start with a little history lesson, because there's a lot of this technology that isn't new. We've had lots of electronics in cars for a long time. You have very intelligent brakes, and I've had intelligent brakes in cars for a long time. We've had factories that were almost completely automated. We've had semi-autonomous vehicles. My first co-op job back very long time ago, they actually had an automated mail cart that followed a chemical trail and knew where to stop because the chemical changed, and it would stop and it would detect people and it would not run into people and not run into walls. So we've had this technology for a long time. We've had embedded systems. There were these things called programmable controllers that actually controlled many things in automated factories. We've had robots for a long time. So I want to tell you a story from my past. My first job out of college, I did factory automation and warehouse automation. And my first job was to replace an automated warehouse. It was the first automated warehouse in the world. So it was very old equipment. As an aside, I actually got to see core memory. That's how old the computer was. The only reason they were replacing this is IBM refused to take any amount of money to continue to maintain the IBM 1800 that this warehouse ran on. The printer was about the size of that space over there. Just the printer. So what we did was we put in a programmable controller and connected it to all of the sensors and all of the actuators. And it was still a pretty dumb warehouse, but at least we got it onto modern hardware. I was telling the story last night. We were all very happy when they said we could have 16K of memory and not just 8K of memory in our computer. That's how long ago it was. So this isn't new technology. The second warehouse I worked on was a brand new installation. And it was much smarter, but it still had a very simple view of the world. You could still get it to do simple things. One sensor would go out, and it would very cheerfully run everything off the end of the conveyor belt because it didn't know any better. It couldn't actually really track things across space and time. So let's talk through an example of what some of the possibilities are. We'll start with what everybody knows. You go to visit a doctor. You go to her office. She takes all of your vital signs, and you tell her what's wrong with you, and you have a conversation. And that's how it typically is done. And you might go to see specialists. There's something called teleradiology now. You actually, as a patient, never see a radiologist. They just see your film. And so there was a company that was formed in India several years ago to actually do radiology for North America hospitals. Because in emergency rooms, if you've got an x-ray or something that needs to be read and it's the middle of the night, you've got to get somebody up. India, being so time-shifted, they had radiologists, they had perfectly well-trained radiologists, and so they gave them contracts. And they shipped the digital file, and so you were seen by a doctor that was half a world away. To telepresence. Now, the doctor sits in their office, and you sit wherever, and you can still talk to the doctor. They can't touch you, but you can have a conversation and talk about what's going on. And now let's talk about, we've got an artificial world. There's an office that's built out there in cyberspace somewhere, and you and that doctor are together in that virtual world. You and perhaps a village health worker are together in a room physically, and that's how you talk to the doctor. And the doctor can see whatever the artificial world allows the doctor to see from how you're interacting with the village health worker. And then we can go to a full virtual reality where you've got a doctor and a robot and a patient, and maybe then you do away with the doctor for some of the standard things. So this is the potential that we have when we get rid of this notion that there is a difference between the physical and the virtual world. So these lines are blurring. We're not looking at the world in the same way that we used to. So this, I think, is a very accurate description. Computation and data communication is embedded in and distributed through our entire environment. This is not just we've got a few cameras here and there. This is all different kinds of sensors, looking at all different kinds of things: video, audio, temperature, humidity, concentration of chemicals in the soil. So you can have perhaps an automated system that is monitoring a field and knows if this particular chemical is not in the right quantity, that they can trigger fertilizer to be spread across the field. It can monitor what the moisture content is. Lots and lots of different kinds of sensors building an internal representation of what the physical world looks like from its perspective. Not just presence or absence, not just video, not just audio, but all different kinds of indicators of what's going on in the world, distributed through our entire environment. So what really is the difference between this new world and the one that we had when I first started working longer ago than I care to admit? Well, first, we have a much higher fidelity model of the world. Those old systems had a very simple model: presence or absence, maybe weight. They didn't have an understanding of what the context was. You only had a very limited view because sensors were expensive. Compute was expensive. Memory was expensive. All of these things were hard to come by. And so we made a very simple representation of the physical world when we were dealing things like automated factories. We've got more flexibility in being able to manipulate the physical world from the virtual. We had very crude mechanisms then, but the precision of robots now is significantly higher. We can manipulate different kinds of things in the physical world in a way that we really couldn't do that before. We've got different ways of interacting between humans and this virtual world. The technology that we have for AR and VR makes it very easy for you to now feel like you're in a different place, feel like you're in a different world, and interact with that world. Militaries have been using training simulators for years, but it was incredibly expensive equipment. The cost of this equipment to allow you to be in these virtual worlds has come down significantly, and the performance that is available is much better at a commercial scale. It doesn't just have to be governments. Improved feedback loops. Our sensors have gotten a whole lot better. We could imagine putting sensors into a field to monitor moisture. That's not that radical of a thought, but being able to have the kind of sensors that are accurate enough, that's something new. We have better feedback loops to understand, okay, if I turn on the sprinklers on my cornfield for 20 minutes, did I get the expected result in terms of the moisture content 4 hours later and 8 hours later? And how might I think about that in the context of the weather forecast, which says maybe it'll rain, so maybe I won't use as much water because then the rain will take care of it, but I've got to get through this period because it's really hot. And we've got improved autonomy and collaboration amongst these things. The various components of that warehouse that I worked on were completely isolated. They talked to one thing, whatever it is they were hardwired to. There was no ability for those different things in the world to interact with each other. They were pretty stupid. Now, we've got more intelligence on these devices. They can interact in different ways. They can perhaps sense the presence of another thing within their scope. Someone was telling me they have this intelligent thermostat that knows if there's no cell phones in the house, they can turn the temperature down, because obviously no one's home. If there's no cell phone, there must not be a person, which I found an interesting assumption. So these things can collaborate, they can sense each other. That wasn't possible before. So why can we do this now? What are the different things that have happened? The first, obviously, is Moore's Law. Even back when I did that first warehouse, the computer that we were replacing was the size of this stage. We replaced it with a machine that was about this wide and this tall and that deep. And then we had another one for backup just in case. They could never do that with the other one. They didn't have enough room. Moore's Law, meaning we've got increased power, decreased size, has had a tremendous effect on this, because we couldn't have had that scale of sensor networks out there for the kinds of applications that we're looking at now. Increased processing capacity with decreased power consumption. It's not just the machines are better, the chips are better, but they're using less power. So we don't have to worry as much about how are we going to get power to these things. So this combination has been critical. And we can't underestimate the value of the communication infrastructure. The fact that we've got wireless signals so many different places. The fact that we have internet accessibility in all of these different places. It used to be that if these things weren't going to be hardwired together, you had to have a closed private network. Everything I worked on was all hardwired together. There was none of this over-the-air stuff. This ubiquitous communication infrastructure, which is getting increasingly reliable, is a major enabler of this. Some people will also say cloud computing. I will agree to that in the context of it definitely lowers the barrier to getting access to this compute power. There was one project that we worked on, the silent herdsman. We put chips on cows that would monitor their movements, and it allowed the farmer to decide, were his cows sick because they weren't moving around enough? Had they gotten someplace where they were potentially unsafe? And also, these were milking cows. When should they be brought in for milking? When was the optimum time to get the highest throughput of milk? And one of the things they realized over time, as they built the model of these individual cows, he started to be able to more accurately predict how much milk he was going to have on Wednesday of next week and 3 weeks from then. He had a model now of not only are his cows healthy, but what is his milk production going to look like overall for his farm, which allowed him to enter into contracts that he wouldn't have ever entered into before. He couldn't really have done this without the cloud. A lot of other applications, I don't think the cloud is a major enabler, but it certainly has lowered the barrier for experimentation, because you can quickly spin up something that will accept all of this data, and then you can start to experiment and see, are there additional pieces of information you can glean? He started out only really wanting to know whether his cows were sick and when was the best time to milk them, and ended up with this much broader model of the overall productivity and health of his farm. So what kinds of things will we see? We've got a progression here, a scaling from the individual to the collective. A few years ago, we called it quantified self. Everybody had one of these, and we knew how many steps that we took, and we might know what our heart rate was doing, But now you almost want to call it smart self, because these things help you understand how you're tracking against your goal. They're looking at not just steps or heart rate, but how those things are interacting. Maybe they have GPS in it so they can follow you around. Maybe they have other kinds of medical sensors in them to monitor blood sugar or something like that. Maybe they're actually communicating that information to your doctor. So we've gone from just keeping track of what we're doing to, again, building a larger, more holistic model of what you as an individual look like and your activity and the way you're interacting with the world. Smart homes. We've got all kinds of neat, nifty devices running around in our home. Smart factories. We're making increased progress. Even when I was working on this stuff, there was the dream of the dark factory, the dream of having a factory that you only needed to turn the lights on maybe once a month, because that's the only time a person was actually in the factory, that everything else was completely automated. We're getting closer and closer to that reality. Smart infrastructure, not just the smart power grid. We can start to automate some of the things. I remember hearing a story when I was working in the UK that the water company actually monitored all World Cup games because they knew of the spike in water requirements every time there was a break in the game, because they knew how many people were watching the game, and what do you do when there's a break in the game? They had to do that manually. They don't have to do that manually anymore. A smart city. There's all kinds of talk about what does a smart city really mean. But what we're really looking at, if you take all of these things together, is it's a smart ecosystem. So I want to talk about a couple of these things in more detail. What does it really mean to have a smart home? You can monitor your power consumption. Maybe you can have a model that turns off power to particular parts of your house when it's not needed. Maybe you can have your house interact with the power grid and switch to different sources if there are different sources that are less costly. We can monitor and regulate our power consumption in our homes. Security. This is one I really don't understand yet. Maybe I'm just too much of a Luddite. But there are people who have locks on their front door that when somebody rings the doorbell, it pings their cell phone, they can see a picture of the person standing at their door, and they can remotely unlock. Now, I don't know about you, but I'm not sure I want the internet to be able to unlock my front door yet. That one I'm not very comfortable with. But we've got much more intelligent, holistic models of home security than we had before. It isn't just, as I have in my home, an alarm system that's connected to the phone so that my house can call the fire department if the smoke detector goes off. I travel so much, I need something like that. Remote monitoring. Sure, we've had baby cams for a long time. Normally, the nanny cam is in another room. But now, my nephew has a camera that he can monitor his cat when he's in some other part. You can monitor your house through these different things. Ambiance. We've all seen these movies in the future where you walk in and say, oh, please play Mozart, or please play something, or please stop that loud noise that's coming out of my child's room. Please dim the lights. Please bring the light up here in the corner so I can read. We can control our physical environment more and more frequently now through voice commands. It can also be pre-programmed if it knows, based on your schedule, that your intelligent thermostat has access to. If you're probably going to be home at 6, maybe it ought to turn the thermos on, or the furnace on at 5:30, because it knows, based on history, how long it takes to warm your house up from its current temperature to its desired temperature based on what the outside temperature is. It has a model, a very accurate model of what heating looks like in your home. Chores. We've all seen the little Roomba vacuum cleaner. We've heard people talk about things like an intelligent refrigerator that can read the expiration date on the milk in your refrigerator and send a reminder to you, or maybe just go ahead and order milk with a specified delivery time when it knows, because it has your calendar, when somebody's going to be home. I still haven't figured out what you would do with an internet-connected toaster, though. That one still astounds me. So a lot of these things that I've talked about are both adaptive and predictive actions. This intelligent home system gets to know who you are, gets to know what your schedule is like, and what it needs to do to achieve the parameters that you've set for it. What is my ideal temperature in the evening when I'm home? What is my ideal temperature for when I'm trying to sleep at night? What is the eco-friendly temperature I want my house to be if there are no people, indicated by no cell phones in the house? It is adapting to the environment because it knows what the outside temperature is. It's adapting to your activities, your behavior, and it has this model of how, as an intelligent, smart house, it can best serve your needs. Okay, what about a smart factory? What kinds of things can we do there besides just getting rid of all the jobs? Supply chain replenishment, a much more intelligent way of managing supply chain, which from a business perspective is a huge cost. Major manufacturers, or major retailers and manufacturers both, have done this for a long time. Walmart makes a lot of its money because of how it manages its supply chain relationship with its vendors, but it puts a lot of effort into that. The more intelligence we can put into this system, the more other manufacturers can take advantage of that. Security and remote monitoring, again, not that much different from what we talked about. Although one thing that you probably have in a factory that you don't necessarily have in a home is the ability to give your employee a badge so that now you know where that person is at all times. Kind of a scary thought. Power consumption, same kind of thing. Factories, particularly depending on what they make, are a huge drain on the power grid. Being able to more intelligently manage their power consumption can actually reduce the environmental impact, sometimes, of power generation. Production line scheduling. If we understand things like what the orders coming in are like, what is the current state of my machines, you can schedule production line. Works together with predictive maintenance. It is a whole lot cheaper to stop a line before it breaks and do preventative maintenance than it is to have a line break. You still have to fix it, but you've disrupted production if you don't know that it's coming. Predictive maintenance is something that is getting a lot of attention in the machine learning space and trying to understand when do failures happen in things like engines and other big pieces of equipment, so we can actually pull them out of production before they break. Fully autonomous experiments. We can start to play what-if scenarios. The more automation we have in a factory, the more we can experiment. And part of why this is important is that in many ways it is easier to tell a machine what to do than to try to retrain a person for an experiment. Particularly if you're talking about having to train a workforce, say an entire production line that maybe has hundreds of people. You're not necessarily going to want to pay that training cost if you're not sure you're ever going to really put it into full production. It's easier to experiment in an artificial world. What about a smart city? Traffic control. As a city learns where the people live versus where they go to their jobs, and what are the different schedules. And maybe they get the employers, the large employers, to feed in, this is what my shift schedule is like, so they understand what direction people are coming from, so they can start to change the cycle of traffic lights. Or potentially, if everybody's using different kinds of apps, they can redirect people to different routes during particular times to miss the congestion. Service delivery. Delivery of goods, but also provision of things. Where are the police going to be at any given point in time? Where do they need to be at any given point in time? Again, things around predictive maintenance, power consumption, urban infrastructure, monitoring what's happening with the water supply, monitoring what's happening with the power grid, and making adjustments to make it more efficient. Adaptive services. When you know the World Cup is coming to town, you know life in that city is going to look very different. How do we need to adapt the timing of the traffic lights? How do we need to adapt where people are? And the smart ecosystem is really the collective. This is how we think about merging these worlds together. There's a model of me. There's a model of my home. There's a model of a factory. There's a model of a city. Now let's combine those models together. And the city model has an API with the different factory models so they understand what's happening there, possibly with the different home models if you're thinking about things like energy consumption. That's what we're talking about with a smart ecosystem, combining all of these different formerly closed networks into thinking about this is the collective. This is what all of the people and the environment and the organizations within this geography are coming together and trying to optimize what's going on within that context. So how are we going to do it? Open standards and protocols. One of the problems that we're dealing with at the moment is you have these different manufacturers who are building these closed systems. Nest has its own protocol. We have various home improvement companies in North America, and they have their own proprietary protocol for all of their devices to talk to each other. When you're looking at these smart cities, you have big organizations who are coming and says, sure, I'll give you all of the infrastructure for free. Just use all of my stuff. Again, a closed network. So one of the things we have to start to push, as we have in other fields, the use of open standards and open protocols, so these different systems can communicate with each other, and we don't have to do these point-to-point integrations. Distributed computing techniques. For a long time, we've been able to ignore a lot of the realities of disparate computational systems having to collaborate with each other. Things do time out. Things do fail. Messages don't always get to where they're supposed to. How do you know who to make in charge? If you want to have kind of a first among equals architecture, how do you know when your current first among equals fails? And then how do you collectively, across all of these independent devices, pick the new first among equals? These are all solved problems, but we've got to remind ourselves of them. Even just something as quote unquote simple as, when did something happen? When you've got thousands of devices out there, you can't assume that their clocks are all synchronized. So it's very difficult to know if one thing happened before another. All of these problems have been thought about and researched literally for decades, but we're going to have to bring it up again. Continued improvements in AI and machine learning. I hesitate a little bit to say this because we've gone through many what are called AI winters. In just 5 years, We're going to have automatic translation solved. I don't know the last time you used Google Translate. It's still not anywhere close to solved. I got a very nicely structured message from someone in one of the European countries. And when I put it through Google Translate, it was almost incomprehensible. If I didn't know that I was actually speaking at one of their conferences, I'm not sure I would have even known what the email was about. We still have a long way to go on some of these questions, but that there have been improvements. We now do a better job of actually utilizing our compute resources to do some of these standard tasks. We're getting more and more dedicated systems that allow us to train neural networks much more efficiently, and those things are going to continue to improve. When we first started talking about neural networks and how they were going to solve all those problems, it was hard enough to have an input layer, an internal layer, and an output layer, and now we have deep learning. That isn't an intellectual advancement so much as it's a compute enhancement, that we actually have the computing power now to do that. We're going to have increased collaboration between hardware designers, software people, experienced designers, usability folks, and people who understand really how to define measurement. As primarily software people, I suspect most of us in this room, when faced with a problem, will think about a software solution to that problem. Increasingly, though, the proper solution to many of these will be a combined hardware-software solution, that there are sensors that you could put out there. A very simple sensor that might actually solve the problem better. But we're not going to find those solutions unless we have better collaboration with people who work with hardware and people who work with software. And these things are going to be so ubiquitous that we need to understand the usability of them. We can't have this usability being done by just people who are experts in the hardware or the software, because we're going to have kids interacting with these things, and we're going to have lawyers interacting with these things, and we're going to have all kinds of different people from different intellectual backgrounds interacting with these things. So we need increased collaboration, and we need to understand the implications of the measures that we are using. It's very easy to define metrics that go horribly wrong. And that's what we're talking about, really. What are the things that are being monitored in that house? What are we trying to optimize for? If we don't tune those things properly, think about managing power consumption in your house. If your system doesn't have the right measurement thresholds, it might cut power to your refrigerator, put it back, cut it again, put it back and forth until it burns out your refrigerator. So we have to think about what are the first and second and third order consequences of the measures and the objectives we're giving this system. Because to a computer, there's nothing wrong with constantly cycling your refrigerator if that's what you told it to do. It doesn't have that understanding of common sense yet. We're still a long way away from that. We also have to start thinking about, as we interact with this digital world, how are we going to design this world? How are we going to make it easy to understand what the world is trying to tell us? I visited recently a university in Australia, and they have literally an immersive data visualization studio where you have your data sets put on the headset, you have your data sets on the wall, and you kind of swipe them over into various configurations to look at the different relationships between data. Apparently, it made all kinds of sense to the scientists who were working with the data. That world was not well optimized for someone like me who was just coming in. It was pretty cool to be able to swipe a data set and have dots appear in this virtual world, but it didn't mean anything to me. We have to think about how we are going to design these worlds and design these interactions to make them as easy and as useful as possible. And we're going to have a discussion of ethics and purpose. We hear this most commonly in talking about autonomous vehicles. There was a study of people about their buying preferences, and everybody said they wanted the auto manufacturers to make their autonomous vehicles favor the life of the pedestrian over the life of the driver. However, when they were asked a different question, which kind of vehicle would you buy, they all said they wanted a car that would value the life of the driver over the life of the pedestrian. We have to have a conversation about this. Does it matter if the pedestrian is a 90-year-old man or a 5-year-old child? We don't want these decisions being made just by companies. These are societal conversations we have to have. Is it okay for your city to sell all of the data that a smart city would collect about you to a company in exchange for free infrastructure? Should they be able to do that without at least the citizens of the city at that time weighing in on the discussion? We need to think about what are the ethical implications of these systems. It's a conversation that has to take place within civil society. This isn't something that we can leave to organizations. More complex systems thinking, particularly when you start to think about how is this going to roll up from me to my house, to my neighborhood, to my city, and how that interacts with my business. We've got lots and lots of different devices with different measurements and different goals, and we need to think about what is the collective impact of this new complex system that we're building. Okay, so what are the risks? Of course, the robots take over the world. Terminator, whatever. It's amazing, though, how afraid as humanity we are about this. When you think about it, many people identify with their profession. Communities identify with the primary employer. We see this very often playing out at the moment in the United States, in some of the coal mining towns. The teenagers, their father was a miner, their grandfather was a miner, their great-grandfather was a miner. They self-identify with the occupation of mining. It's a part of their identity. As humans, we are worried most, and this comes from a study from a woman by the name of Genevieve Bell, who's an anthropologist who works for Intel. We are most worried about becoming irrelevant. It's not so much that the robots take over, it's that the robots decide they don't need us anymore. That's what we're most afraid of overall. Increased centralization of data and control. We're seeing this play out with Facebook, with all of these different data breaches. All of what I'm talking about here could imply an increased level of centralization of data. And obviously, the more we give control of our physical environment to machines, we're ceding that control. Humans just can't keep up. Computers can do certain kinds of processing so much faster than we can that it's not that hard to imagine that we're not going to always understand what they're doing anymore, so we can't keep it straight. This is actually in some ways a variant of the robots take over the world. What happens when we no longer feel like we understand enough about what the machine is doing that maybe we might decide to counteract it? What happens when we have to just say the machine is always right? Personally, knowing what I know about the current state of AI technology, I would want to be able to still question the machine. That might be different in 25 years, but now we really do still want to know why the machines are doing what they're doing. Machine speed feedback loops. We've already seen this in the automated trading arena, where actually one organization was bankrupted because the automated trading happened so fast and they didn't do continuous delivery, and one of their machines was running an old version of the algorithm, and it bankrupted the company before they had a chance to figure out what was going wrong. With all of this level of automation, these feedback loops and these failures are not going to happen at human speed, they're going to happen at machine speed. And what are the consequences of that? Data privacy should be an obvious one. How much do we really want people to know? I might be perfectly comfortable with my health statistics being sent to my doctor. I might not be quite as comfortable with that being sent to an insurance company or an employer or a prospective employer. What are my rights around the data that's being collected on me? And this certainly has the potential to increase inequality even from where it is right now. Exposure to hardware failures. Until we're really sure we know how all of these control systems are going to work, there are going to be some very interesting failure modes that we don't anticipate. And the more you have humans out of the loop, the less likely you are to have somebody notice it immediately. So we're going to have to think, how are we going to detect these hardware failures? And we're going to have to expect that at least until we know more about how these things work, we're going to have some pretty spectacular hardware failures. Security, this one should be obvious too. Part of the reason we're able to do this now is the decreased cost of a lot of these devices. But what that means is that those devices are pretty simple, and they're stamped out and mass produced. And so we have all of these cameras with default security passwords, and not necessarily a very easy way for you, after you've bought your baby cam, to put your own password on it. So we have these baby cams out there, and anybody can watch the baby if they stumble across the right IP address. Should be a scary thought. Again, cameras. There was a DDoS attack carried out by over 140,000 cameras that a hacker was able to take control of. There was a university whose internal network was shut down by their vending machines. Again, all of these were because of things like default passwords or old firmware that hadn't been updated with a security patch. The more devices that are out there, the more we increase our attack surface. We're going to have to figure out how to keep the security systems in these devices up to date against threats, because there's just going to be more of them. So why would we do it then? Doom and gloom. Why would we worry about robots taking over the world? Increased productivity, efficiency, and revenue. From an organizational perspective, this makes perfect sense. Decreased cost, decreased waste, and improved environmental outcomes. That last one is starting to get to what the rest of humanity might like as well. Can we limit the impact of the things that we do on the environment? Can we understand enough so if we decrease our use of resources to get the same level of benefit for society, maybe we can lift more of the world up without destroying the planet? Safety, repeatability, and reliability. Robots don't fall asleep. If they have a steady power source, they're just going to continue to work. They don't come in hungover. They don't get sick. Unless you're like that little Microsoft bot, they're not going to talk back to you. They're going to do what they're told, at least until they take over the world. So there is a sense of reliability that comes from this. What they can't do, of course, is respond to a situation they've never seen before. But in a controlled enough environment, we're going to have much greater reliability and safety. Access to expertise regardless of location. We can have experts in different medical fields providing medical care in rural India, in rural Africa, in the Amazon, in places where that specialist could never get to. Protection from harsh and hostile environments. If we've got good enough sensors out there, you don't need people going out to explore these environments. If you've got an intelligent enough robot, you can send something in to a nuclear plant that has had a meltdown and actually make safety repairs without having to send humans in there. So we can protect ourselves from these things. We can increase the capability. We can empower humans as opposed to replace them. In many jobs, a lot of the stuff is the same thing over and over. All of these, 95% of these test results are blindingly, obviously good. But in many cases, a human has to go through those 95% blindingly obvious good, and by the time they've gone through that, they might miss this really strange thing. Even if you have a higher false positive for your first scan, let the computer, okay, so maybe he only finds 90% of the blindingly obvious cases, and you've significantly reduced the workload on the human so that the human can focus on the things that might be different. You can have the human focus on the things that humans are best at, which is dealing with situations that we haven't seen before, which is drawing inferences from things that we haven't thought to relate yet. So we can actually up the overall performance of a human by taking the simple stuff away from the human. Improve situational awareness. We know more what the world is really like because of the sensors that are out there. The farmer knows what is the level of fertilizer and moisture in his field without having to go out there himself. So, what can we imagine? We are the people who are going to be constructing these worlds, working with hardware designers, working with usability people, probably working with ethical ethicists. I think that's how I pronounce it. But we're the ones. How can we start to think about what is the way that we can improve the world by deploying sensors, by creating artificial worlds, by creating spaces, models of organizations and individuals and collectives of individuals to help us provide better outcomes? What would the world look like? What can we imagine? And what is our responsibility? We are the ones who understand technology. We are the ones, therefore, that need to be asking the questions. What is the right body to decide whether it is the pedestrian or the driver who should take precedence? What are the questions we need to ask about that? We have a responsibility to raise those questions in a way that no one else does. Maybe in 30 years, our politicians will understand this well enough that we can leave it to them, but right now they don't. Technology is changing too rapidly, and so it is our responsibility to make sure that people understand what are the choices, what are the risks, what are the benefits, what is the potential, and to start the conversation as well about the trade-off between the benefits, which are undeniable, and the risks that are real, and how we should safely proceed. What are the experiments that we can run to start to see the benefits? Where are the risks right now too great of something like a machine speed feedback loop that might bring down the electrical grid or might flood a town. It's our responsibility at the moment. We as technologists have to take the responsibility to raise these questions. We can't just be blind order takers. Thank you very much.